Hello, my name is Irmik Zakupov, and now I'm going to demonstrate you experiment number 1. In this experiment we are going to work with 3 logic gates, AND, NAND and NOR. And also we are going to use integrated circuits to implement these logic gates in our circuit. Firstly, let's look at part A. In this part we are going to work with AND gate. Now we can see our Boolean expression, the symbol of AND logic gate, and also truth table. Now let's look at our circuit that is made in Tinkercad. Here we can see that we have 2 switches that are our inputs and also integrated circuit. Firstly, I should mention that our switches are connected to inputs of integrated circuit, and also in third pin we have output that is going to resistor and LED. In this case, LED we need to check to determine the value of our output. So let's start it, and as we can see that when our switches both on, our output also is 1. And as we can see, if one switch is off and one is on, output equals 0. And as we can see, only when both switches are on, our output is 1. So, based on this information, we can make this truth table. And as we can see, it's our data is consistent with theoretical data. Let's move on to part B. In this part we are going to work with NAND gate. We need to build the same circuit, but we just replace AND gate by NAND gate. Here we can see our Boolean expression, symbol, and also truth table. Firstly, I should mention that NAND gate is a combination of 2 logic gates, AND gate and NOT gate. It means that our output inverts. We invert our output. And let's look at our circuit built in Tinkercad. Here we can see that we also have 2 switches, A and B, that are our inputs, and we have also one output that is going to LED. And as we can see, our LED is on in three cases, and it's off only when 2 switches are on. And based on this information we can make this truth table, and when we compare it to theoretical truth tables that were given in manual, it's here, we can see that they are the same, and it means that our circuit is correct. And let's check last part. We need to do the same, but we're working with NOR logic gates. NOR logic gate is a combination of 2 logic gates, OR and NOT. It also means that we invert our values that we can get when we're working with OR gate. Let's check it in Tinkercad, our circuit. As we can see, we have 2 switches, A and B, and also we can notice that here we use second and third pins for input, and first pin is responsible for our output that is going to LED. Let's start it, and as we can see, LED is on only in one case, when both switches are off. And then we can make the next truth table that is consistent with our theoretical data. And in conclusion, we can state that all our data that we obtain from our circuits is consistent with theoretical data. It means that all our circuits work correctly.